So this is your cathode ray oscilloscope. Cathode ray, anyone knows what that means? Cathode ray. After Thomson, anyone? Cathode ray is just a beam of electron. Okay, so an oscilloscope allows us to play around with this electron. How fast it's oscillating, we can use that then to measure the frequency. Okay, so onto the screen first. What did we say about these little grids? They're 1 centimeter each. So the two buttons that are of big concern for you today, right, is your time base and the volt per division, your Y gain, right? And we need to read the signal. What's the frequency? Well, I can't see the whole trace, right? I need to adjust the trace. So the first thing I'm going to talk about is the repositioning of the trace in the x-axis and the repositioning of the trace on the y-axis. Let's have a look. Where's my x shift, x position? You see what I'm doing? I'm shifting it right and left. Yeah? And then my y shift, y position is this one. We're moving it up and down. But the signal is still too big. So what do I need to do? I need to scale it. So for me to be able to scale it, I could use the time per division, or I could use the volts per division. Volts per division is the y-axis. And look at it. So do I go up or do I go down? I go up. Because when I go up, more voltage for the same centimeters. And let's see. So this is 1, this is 2, this is 5, this is 0.1 to the right. So I go left. And can you see I made the trace smaller? Right? So if I want to measure from the top to the bottom now, what I'll do now, I'll try to reposition my trace using the vertical one, which is my Y gain. Can you see that? Yeah? So how do I read that? It's a bit difficult, isn't it? I just want to measure from the top to the bottom. There's something that I can do. Anyone knows? Yeah. You could turn the time base off. Because I'm not interested from the peak to the peak. So the time base button is this one. If I was to read this, where's that X, Y, X position? That's the X position, isn't it? If I read that, that's probably 1, 2, 3, 4, 4 point something. There's a high uncertainty. You can just by looking at it tell me what to do to get a better reading. Can you see what I did? I moved it to the center line. Why the center line? It has subdivisions. If this big line can measure 1 centimeter, 2 centimeters, 3 centimeters, guess what the center line can measure? 0.2, 0.4, 0.6, 0.8, and then 1. Reduces uncertainty, doesn't it? Yeah? All right. So that's how you do that. Now, I'm going to switch my time base back on. And I'm going to try and measure from 1 cycle. So what do? That's 1 cycle. It's around 2.2. Is that how I do it? What do I do? To get better, reduce uncertainty again. Instead of counting 1 cycle, how many cycles can I count? I count over a longer range. Remember, they asked a lot of questions about year 12 uncertainties here. So what you do, so can you see what I'm doing now? I could start counting from here. So that's 1, 2, 3, 4, 5. And what am I going to count? Am I going to count here or I'm going to count on that central x-axis? Why central x-axis? Again, it's got higher resolution. That's it. That's what you need to know about it. So 2 things. X shift, Y shift. What do? Move your signal up and down, right and left. What do these 2 now do? So the Y gain control, which is this one here. What did that do, guys? It just allows you to scale up vertically. Would you like it to be too small? Would you like it to be too big? No, just right so that you can read it. And if you're reading, try and center it in that center one because it's got smaller divisions. And what's the other one called? Time-based setting. Why are we using time-based setting? Look at it. Look what happens when you increase time-based setting. Too slow. Too big. Right? That's sort of a good one to measure because you can measure from the sub-intervals. Okay? So, for example, now let's say we're measuring something of a very, 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 very high frequency. It's very, very hard to read, isn't it? So what could we do? We could zoom in. If I were to zoom in, do I increase or decrease time base? You're zooming in, you're going smaller intervals. So you would be decreasing. Can you see I'm going, this one has got 0.1 second, this one has got millisecond, this one's got microsecond. So I'm zooming in. That was another problem that students faced when it came to